Hello, everyone, and welcome to our 14th Lectures at Home session. We had some starting issues with our stream. Sorry about that. Yeah, today we have Malte Reimann here, and he will talk about cloud fundamentals, Doodle, jump to the cloud. As usual, if you have any questions, do not hesitate to send them in the chat, raise your hand, or just ask them. So then I will hand over the microphone to Malte and enjoy the session.
Hey, so when did I start to understand cloud computing? Well, reading all those blog articles and seeing what the market does certainly gave me some understanding, but it wasn't the point where it clicked for me. Sure, Amazon is printing a ton of money and Microsoft as well, and the cloud is fantastic. But for me personally, I only started to understanding what the cloud really means about 3 months ago during a project at university. As a team project, we developed an application that we deployed on a Kubernetes cluster. However, because the university still has its own data center, we couldn't have enough nodes. And once you hit that physical limit and you can't deploy any more nodes, then it's over. You just hit that physical limit. And that's where I understood what the cloud really means is we are all so used to having our songs, our video streams, all on demand on a click of a button. However, and the cloud enables just that when you come from the perspective of a business where you have your data center, which has a physical limit that you can overcome by a more distributed model of the cloud. I don't know what your story is about the cloud, what your understanding of the cloud is, but in this talk about cloud fundamentals, I want to highlight the key concepts. However, because personally, I'm not well at learning by reading text or looking at presentations, I decided I want to switch things up. I want to present the key concepts about the cloud to you the way I learn the most. Personally, I know I'm a haptic learner, and you might be a different learner. But today, if you know that you are familiar with visual learning, or if you are a haptic learner as well, you might be able to relate to this concept. So let me share my screen. All right, we are still in an Office application, but not your usual PowerPoint presentation. Instead, I learn by writing. Phrase or definition 100 times, and I know I can remember it. So maybe this talk will also inspire you if you are not sure yet what learning type you are. Obviously, I'm not going to draw live out everything here, so I prepared some, but I think it will be a visual fun story about cloud fundamentals. First, let's start off by looking at the why. I alluded with my story in the beginning to the fact that managing hardware and software is complex. Developing software can be so much easier if you don't have to worry about all the underlying infrastructure, about every single compute instance, about every single CPU, about every single configuration combination, about all the networking. So this is the main motivation for moving to the cloud. But there are many more benefits. And these I have summarized in the following key concepts. First, high availability. Second, scalability, elasticity, agility, fault tolerance, disaster recovery, global reach, a predictive cost. You don't need those expensive infrastructure skills. Your productivity might go through the roof, and you have advanced security. I know those are a lot of concepts, but looking at them in more detail, they actually make sense and they are awesome. So high availability. This simply means that because you are not responsible of the underlying hardware, and somebody whose everyday job it is to make sure that the hardware is running for you, they can ensure better that the hardware you need is running 24/7 all the time. Second, scalability. I've mentioned the Kubernetes cluster where the nodes on the physical server or the physical server were limited. Scalability, on the other hand, means that no matter what your workload is, you will be able to find or to get the resources you need to run this workload. And there we have two aspects. One is scaling up and the other is scaling out, also referred to as vertical scaling, where you increase, for example, the CPU capabilities. You might start out with a simple web application where 8 gigabytes of RAM are totally fine. But then over time, your application develops and becomes more complex, and you might need to scale up to 16 gigabytes of RAM. Scaling out, on the other hand, or horizontal scaling, means that you take one application and you duplicate it. So instead of running one web server, you might want to increase it to 2 when you notice that the demand requires it. Agility is just the fact that you can iterate more quickly. We've all become accustomed to concepts like Scrum or other agile methods. By the way, here I want to reference the lecture we had last month about where we had not specifically on Scrum, but on the retrospective. So I highly recommend you check that out. The cloud simply allows you to be more agile because you have a lot of you are on a higher level of abstraction. Depending on which cloud model you choose, you might only have to develop the application itself. So the deployment becomes as easy as clicking a button, and as such, you can deploy every 5 minutes. I don't know, but it's up to you. Fault tolerance means that when we have a node here or two nodes that are connected maybe through a network and the link has a fault, the cloud is able to automatically establish a new connection because of its distribution and its availability to switch the workloads from different servers, and you are not bound to some physical boundaries like with a regular data center. Back to elasticity. This means that you might want to change the cloud is simply more flexible to the workloads you have. So I want to illustrate you with the graph here. So let's say we have the website again, and we have time and the traffic, and most likely your demand for the website will look like some kind of janky curve where on Mondays it might fall, and then towards the end of the week, more people might be buying on your web shop, so it will rise. If you have some static allocation of servers, you're either like the red line, way above, you have too many resources allocated and you are not utilizing all of them, or you might have not enough resources allocated for those peaks. That's the property of something being static. It doesn't change over time. However, because of the elasticity of the cloud, it can adapt to the usage. So this we can see with the green line, where depending on the demand, you might allocate more resources to meet this demand, or you can also scale down and deallocate the resources that you don't need, so you're not paying more than you actually are using. Well, if your data center burns, your data center burns. And if you don't have redundancy, you might lose everything, all the data, all the compute, the entire investment. The cloud, however, can easily recover from such a disaster because it's not just bound to one physical data center. So if one data center burns, which in of itself is unlikely to happen because of high security standards and procedures. However, in such a disaster case, data that is distributed across multiple physical locations can be more easily recovered, and you are not burdened by the task of rebuilding an entire data center. Instead, somebody else is responsible for recovering from the disaster, and you gain all the benefits. Simply, global reach means that because the clouds we have, the public clouds we have today, are interested of providing services to as many people on the world, on the planet as possible, they have data centers in every region. Here, located in Germany, as a company, I might only have a data center in Germany. And then if I want to expand my product, because it seems like the people in Asia also like my website, I will have a problem because my data center is quite far away from Asia. And even though with digital technology, the distance seems to be getting smaller, it does matter because all the traffic has to travel through the internet. So by using a cloud provider, I can easily deploy my web application also on a region in Asia. So my new customers I won over have the best service they can get. Predictive cost, we will come back later in more detail, but basically it means that if you want to, you can have contracts that go longer periods of time. So the cloud provider can guarantee you for a set of resources that you are going to pay a certain amount of money. Whereas if you are building or maintaining your own infrastructure, you might have an storage drive, so an SSD might get corrupt and you might need to invest in new hardware, you need to update, upgrade. So all those expenses are not predictable. Furthermore, to find all the people that can upgrade your storage and maintain all the hardware is not easy. We all know the skill gap in IT skills, but hardware skills are especially hard to come by and expensive. So finding the right people to maintain your data center might not be easy. Productivity sums some of the key concepts from above. So, for example, agility itself might lead to more productivity. The same aspect as I told you earlier, that if you can deploy more often, if you can get feedback more often, you are able to iterate more often and be more productive. And you don't need to worry about all those nitty-gritty hardware configurations that cost so much time and energy that you could better invest in building the best service for your customer. The final concept is security. This one is quite obvious. If you pay somebody who is responsible for, or who has the responsible for all of your hardware, you bet that this person is gonna invest quite a lot of money and resources into making sure that your data is safe, because otherwise they would lose you as a customer and lose your money. So by having somebody that is dedicated and has the reach of as a cloud provider has drastically improves the security. During the predictive cost key concept, I mentioned that I'm going to dig deeper a little bit on that. So this is actually quite simple, and it comes down to economics of scale. We have heard this term in other scenarios, for example, streaming or ads or social media, where it's kind of like the winner takes all concept. Here, this also applies, because if you are not managing only your own server, or if you are only managing your own server, you have lots of expensive just for yourself. If you are providing servers or compute or cloud services as an cloud provider, you can save much money in buying hardware in bulk, optimizing processes in a data center, and as such provide a cheaper service for your customer. From the customer perspective, on the other hand, it comes down to the fact that you have, on the one hand, capital expenditure. So when you plan on building a new data center to host your web application, you need to pay a lot upfront. You need to have a property, you need to build a building, you need to get all the hardware and everything wired up. Operational expenditure, on the other hand, occurs more when you are using a cloud. Here, you are not building a new data center for your web servers. You are paying for the server to run your web service. So you are paying only for what you are actually using, and you don't need to pay in advance. Let's have a look at some different cloud categories. The first that we are all familiar with is public cloud. Public cloud simply is, for example, AWS, Azure, the G Cloud. This means that it's publicly available. Everyone who wants to take advantage of those clouds can pay the cloud provider to use their services. The private cloud is the opposite. So here, you have a company that owns the data center, and they are not providing their services to everyone. Instead, they are providing their services for a certain set of customers. This is kind of tricky to understand, I think, because it seems like it's about a regular data center, but there's even a difference there. So in traditional sense, when a company had a data center, they also had an IT department and they would do all the IT related stuff from development to deployment. In the private cloud, however, you still might have the one company with the data center, and the company who owns the data center is the only company who actually uses the data center. But instead, within the company, the data center is provided to other substructures in the corporation. So here in the private cloud, the IT department takes more of the role of the cloud provider, where they might provide the computing and infrastructure and storage and networking to the finance department or the HR department. And then the IT department is not only the single department utilizing the private cloud or the data center by developing application. You might even have some other departments developing applications. And then there's something in between, which is the hybrid cloud. And this simply means that you might want to retain some of the workloads you have in your private data center. So especially the ones that are highly sensitive or that are legacy applications. And then on the other hand, you have some applications or some parts of applications even that you can easily deploy to a cloud. And then there you might want to use the benefits of the cloud that I explained above, or the by using operational expenditure and paying less. And there, the hybrid cloud then connects those two. So the data center your company owns and the data centers of the cloud provider. And you can build a seamless infrastructure with both applications running on both types of clouds. Now, there are three really funny abbreviations. So ISS, which means infrastructure as a service at the low level, then platform as a service or PaaS, and software as a service, SaaS. And they are in themselves really well picked words because they are exactly this what they say. So software as a service means that you are paying for using software. Over the last years, or even over the last decade maybe, we've become accustomed to renting software rather than buying a physical copy. So think about your Adobe Creative Cloud or your Office subscription. Here, you are only responsible for managing the users and maybe the functionality of the application itself, but you basically log in and use the application. And by the way, if you're wondering, I know I'm aware that there's a newer fancy looking Office logo. However, I draw the old one because it's easier to draw. So sorry about that. Then platform as a service is the concept of a level lower. So you are not only using an application, but you're rather developing applications. However, you are not managing anything below the application. So, or not deep below. So you don't worry about servers and hardware. And the most illustrative example of this is Azure Functions. So here you are literally just writing code and uploading it, and then the code runs depending on when the code runs when it is triggered, and you don't know on which server it runs. It isn't even persistent. So maybe if your function isn't used, it might get stopped, and then when it is used again, it will be started on a completely different server. The benefit of this is that you are not responsible for managing the runtime. So you are only responsible for the actual code that you write and not any configuration. And you are obviously paying less because here, and this is why I like this example so much, you are actually just paying the minutes that you are using where your function is used. And then there's infrastructure as a service. So this is the most fundamental level of any cloud. So here you are actually renting compute and networking and storage. Obviously, here you have the most control because you are basically renting hardware, but you also have the most responsibility. And this is summed up with the shared reliability and shared responsibility model. And we get back to this in a second. So I've given you a broad overview of the fundamental aspects of the cloud. And now I want to go into some specific details of the Azure cloud. Here we have the right. So the core fundamentals apply basically to every cloud provider. And on an abstract level, the cloud providers are all the same, but then every cloud obviously has its own quirks and features and different namings and different ways of organizing things and even different price tags. So here I want to give you a brief overview of some key aspects of the Azure cloud, mostly because that's what I'm most familiar with, and on the other hand, because I want to have this talk geared towards people who are interested in taking the Azure Fundamentals exam or the certificate. So those are some key aspects that you should definitely have on top of your mind when taking this. I've already talked about how the data centers in the cloud are distributed all across the globe. And this distribution follows a hierarchical organization. So on the top, the world is divided into different geographies in Azure. So you have Asia, you have Europe, you have Africa. And then within each region, within each geography, you have different regions. So within Europe, you have different regions. So for example, you have West Germany or East Europe. So they are not specific to any country, but they are smaller units within geographies. And then here it makes a little cut because geographies and regions are already the main aspect to keep in mind when deploying things. However, there are some fine details that are actually quite interesting and reflect the concepts of a cloud. One of which is availability zones and the other is availability sets. And personally, I don't know who came up with those names because they are so similar that they are so easy to confuse. But let me explain. Availability zones are within a region. So if the region is the lowest unit you can deploy to, for example, back to my website, if I am going to deploy my website to the region of East Europe, I don't get to pick the specific data center. So Azure itself has different physical locations within East Europe, but you don't get to control it as a customer where in this region your application runs. However, what you get to control and what you get to take off are the benefits of the cloud concepts. And here comes availability zones. And so availability zones guarantee you that if you have your applications running on 2 different availability zones and one availability zone goes down because of a fault, the other availability zone will always be available, hence availability. So in an example, this is easier to understand. You might, and maybe it's easier to understand with, let's say, Asia than instead of East Europe. If you, for example, deploy your website to a region in Asia, let's say Japan, and then there might be a earthquake or a tsunami. So maybe an entire row of data centers might get wiped out. But because of availability zones, you will be able to specify different availability zones, and then Azure will guarantee you that, or they have taken thought into this, that if one part is wiped out with a tsunami, then the other zones are in such locations that they will less likely to be impacted, and as such, your entire workload can switch to a different zone and still be available, even though a lot of data centers got wiped out. And then availability sets goes even further, even more granular level, where you're still only able to choose the regions with availability sets. You can even you are even ensured that there are different your application, or this applies more to virtual machines, that it runs on different server racks in one physical server. So with this, you have even more redundancy and or even better chance of fault tolerance or disaster recovery. So the geography and region is just to get sort of an idea of the hierarchy. Then let's take a look at some of the services that Azure provides. This is going to be a more of a high-level view because there are so many services, and if I would list them all, we would probably be still sitting here tomorrow. So on a high-level view, you have the available. You are able to buy compute as a service. So this might be your virtual machine, the Azure function, so anywhere where you have something that you need to execute. You can, to some degree, think of this as this being your CPU, but maybe think of it as a little bit more abstract level, since you might not actually have like one single physical CPU, but more like something like an Azure function that is a little bit more dynamic and more abstract. Then we have networking as a second category, and this includes different services. So for example, you might want to connect in the hybrid cloud scenario with your on-premise network. So most companies have some virtual private networks set up, and you might need to connect to this. You have different other services like load balancing, where you are distributing the requests that are sent to your application to different nodes in the cloud. And then when I scroll down, lastly, we have data as a category. So here, it's like your hard drive or your SSD that you want to store something. Your applications likely want to operate on some kind of input, output. They need to persist some things. So you need to pay for this. You have the difference between structured, semi-structured, and unstructured data. So structured is your classical SQL database where you have some schema after which your data is organized. Then semi-structured data is might be some table storage where you also have some structure but not defined by a schema. And then unstructured data might be just the blob storage where you just upload some files, some images, some binary data, and you don't have any schema to operate on this. Here are the examples that fall under the different categories that are provided by Azure. So you see from the left hand to the right hand, you have organized data sources that are often more complex. Then you have, for example, in the semi-structured area, something like CosmoDB, where you can run no SQL databases. And then on the right, you have files and so on. And yes, there are many, many more services that I don't want to go into detail. I want you to remember those three categories where you can put all the services and categorize them: compute, network, and data. And if you think about this, that's probably the most important parts of your applications as well. You need to execute something. Most applications need to communicate somehow. So other applications with your user, your customer, and then if you have an application that doesn't need to store anything, good for you, but most likely you want to be able to store some data. Then, on the other hand, or furthermore, drilling into the functionality that Azure provides, we can, let me scroll down a bit more here. We can look at some solutions. So these are less specific and more broad. And they often build upon the three categories I mentioned before: compute, network, and data. But they might bring more functionality or combine different services and from different categories to provide a greater solution. And one example here is IoT. So Azure provides different solutions and services in the IoT space. So this basically means that you can move to an even higher level of abstraction where you connect your different IoT sensors, and then the IoT solution is already configured in a way where you have the right compute setup and the right networking. So everything can work together. The same goes for the analytics category. So probably the buzzworthy one here, machine learning, AI. Azure provides solutions for this, from easy to use services like custom like vision services or speech services, where there's already a model developed by Microsoft that you just upload your images to, and it analyzes them and it gives you a response. So it's actually like machine learning by clicking a button, over to more less specific machine learning workflows where you have to do more of the work, where you maybe or Azure provides solutions where you can train machine learning models, where you can deploy them, and more moving towards the role of data scientist than just wanting to use some machine learning solutions. And lastly, Azure provides some solutions for your development. So especially now with the GitHub acquisition, you can think of this as the integration of the services with your code. So you have your code somewhere, and then if you want to deploy it, it's better if you have an easy way where you can just set up an GitHub action or and have it continuously deploy to the cloud. So Azure provides endpoints for this. Now, this security aspect I wanted to include because obviously security is so important, and also because it all ties back again to the shared responsibility model. Security can be thought of as there are different layers of security that each layer is further away from the valuable data that someone might want to steal, that is valuable to protect, to secure. And with every layer that from the outside going in, one might breach, they get closer. But then there's another layer of security. So first, we have the digital security, the physical security, then the identity and access layer, then the perimeter networking, compute, and then the application security, and then finally all the way into the onion, we have the valuable data. And here, this onion model also depicts the shared responsibility, because your responsibility is at the bottom and goes up, but your responsibility decreases from the inside layer to the outside, depending also on which kind of solutions you use. And the cloud provider's security goes the opposite way. The cloud provider has the most responsibility on the outside, and then depending on which solution it goes in, and both of you meet and you have the shared responsibility. So, for example, the cloud provider main responsibility is, of course, the physical security. So they need to protect the data center. And yes, we often forget about those aspects because we mostly never see them, but they are heavily guarded. And then depending on which model, the cloud provider will also manage the identity and access. So for example, when you have the software as a service model, then Adobe is also taking care of the identities of its users and that they have the right access permissions when they log into their Creative Cloud. You, on the other hand, have your most responsibility about your data. So you still pretty much own the data that your applications gather, and you need to make sure that you have in place mechanisms for the user to see the data and edit it and delete it. And you're also responsible for only collecting as much data as you need. Because if you don't have tons of data that you don't need, then there's not too much to steal. The application layer also mainly falls on you, in the sense that you need to make sure that the application you are developing is up to date, that you are not using vulnerable dependencies. And so I hope you can visualize how the responsibility, depending on which kind of solution you have deployed. So if you have a system as a service, the cloud provider has the most responsibility and you the least. If you're using platform as a service, the cloud provider has less responsibility than compared to system as software as a service, and you gain responsibility. And then infrastructure as a service is where it's flipped, so that the cloud provider has the least responsibility and the most responsibility is on you. And those are moving in opposite directions. So responsibility versus flexibility. Here I've listed some of the aspects for security specific to Azure. So there's the Active Directory, which is like, in a nutshell, it's that sign-on pop-up that you always see when signing into applications. However, with it, there comes a whole lot more. That is where it becomes a platform in itself for authentication. So for making sure that the person that's logging in is the person that is actually who it says it is. And then authorization is where it's about making sure that the person that is logged in has a specific set of permissions, and it also only can act based on those permissions. So if I'm not authorized to delete users in my application, then somebody needs to make sure that I'm not going past the permissions that I have. And the Azure Active Directory does exactly this. So you can set up authentication with different authentication provider, and there's a whole standardization below Active Directory. So it works with different kind of accounts, not just Microsoft accounts for login. And then authorization is where you can define for your application the different kind of permissions that users have. So one user might be an admin and gain some permissions with that. Scrolling down, I've written down some the four aspects that I think that actually quite interesting is that even though you are kind of giving up some of your flexibility or some of your ownership, in the sense that you don't have your own data centers anymore, there's still an incentive for the cloud provider to provide you with privacy and compliance to regulations and to gain your trust. Because here it comes back to the whole provider and customer thing, is that if you're paying for something, the person you are paying wants to make sure that you're receiving the best service. So if they have a data breach, they are losing their customers. And here, what it seems is that Azure is well positioned in the sense that they have many certificates that you can look up, and there it becomes really specific to the type of industry you are in, where you might need some more compliance or less. But in general, it's always a good advice to maybe look at the certificates or even the policies that are in place to base your choice of your cloud provider on such core fundamental ideas. And then finally, this is the last point here, is the pricing aspect. So we've already seen in the key concepts that in general, the cloud, because of economics of scale, allows you to pay less. And here Azure has different pricing models. So the free one is pretty self-explanatory in the sense that you can sign up for an Azure account. You can manage the things you want to use through the Azure portal, and there are services or subscription where you don't pay anything. This is obviously quite interesting for students because they have a student subscription, and there are quite a few services that are free to use in general, and then you get some credit that you can spend without having to pay anything. And then there are two different pricing models. So when you're actually using a service that costs something, most of the time you pay for the usage you accumulate. So you most likely will get like a monthly bill, and then it will list all the resources you have and the usage of those resources, and then it will calculate the amount you will have to pay based on that usage. Offers are probably rare, but I want to include them for having a complete picture. So maybe if you are certain that you need a resource for the next 3 years or 5 years, Microsoft has or Azure has some offers where you make a contract more long term, and then they can cut the cost even further because they know you are paying them or you're using their the resources for the next 3 or 5 years. So you're also paying based on your usage, but you already set up a fixed contract for a fixed period of time and a fixed amount that you will pay, and it will be less than if you would go the same period of time, only pay as you go. This aspect, the groups, come back to how Azure is organized. And this is actually more interesting, again, if you're taking some sort of exam, because first, I highly recommend you that you just try out deploying some services, and then you will get a sense of this. But besides the regions where data centers are organized, there's also a hierarchy for where the services and the resources you deploy are organized. And from top to bottom, those are the management groups, the subscriptions, and the resource groups, and then the resources themselves. So resources themselves are, for example, the virtual machine that you're using. And then around that, you have a container that is a resource group. So you can combine different resources into one container, and this helps organizing things. So humans bring like structure, and you can organize this however you like, but you might have some one resource group for that one project. So let's say I have my web project for my web shop, and then I have different resources that I need for this. So I can put the database, the virtual machine where my web server is running on, all in the same resource group. And I get then an easier way to manage them, because I can delete them all at once and I can make changes to them. Then furthermore, higher up, you have different subscriptions. This is also quite easy to understand, in the sense that you might have a subscription with your personal account or a subscription with your school account. And then within those subscriptions, you have, of course, your different resource groups. However, you can even use subscriptions for more fine-grained control. So maybe you want to have one subscription for development, where you're having all your services and resources that are in development, and you then get billing just for the development resources. And then you maybe have a subscription where you have your production resources running, and then you can even further separate. And then the management groups on top allow you to bundle different subscription within, let's say, one company. The last really interesting aspect is the service level agreements, and they are just fascinating from a numbers perspective, in the sense that service level agreements mean that Azure ensures that some services are available X percentage of time. And those numbers can be quite high. So I've listed them here in this graphic, but I think pretty much there's no service level agreement below 99%, and they go all the way up as high as 99.999%. So this is the percentage of the time that your service will be available running. So pretty much in the worst case, when you buy a service, it will be running 99% of the time. And in the best case, you have some services that are pretty much only offline in like a minute or a couple minutes per year. So this is really good if you think from the aspect of otherwise I would have to manage my own hardware. And if it goes down, I will spend lots of time to repairing it, to making sure that it's up and running. And here I have even a guarantee of the service running. So this concludes my talk on the fundamentals of cloud. All of these aspects can be explored in much deeper fashion, but I think those are the high-level concepts that you should definitely know and have heard to have an understanding of the cloud. And if you have any question or if anyone wants to provide their point of view on what they think the cloud provides for them and which of the concepts is more important for them, I'm excited to have some chat. I'm grateful for your attention, and I hope you could take some things away, maybe from the standpoint of how do I learn? Maybe you want to explore this a little bit more. Maybe you want to start doing your own graphics and your haptical learning experience, or maybe even from a technical perspective that you could learn a little bit more about the cloud concept. Thank you.
Okay, thanks a lot, Malte. Do we have any questions here? Or in the YouTube chat? It seems not to be the case. Let's wait perhaps 1 minute so that the people from YouTube can join or write their questions down.
I'm definitely seeing in our Teams chat here. So if you're not in the Teams chat, I highly recommend you can always join us there. But we have some comments there, and I've just seen that presenting with the OneNote history functionality needs some more refinement. It's not quite as easy as I thought, but I hope you enjoyed the icons and the drawings.
So in my opinion, it was a really different concept as the usual ones. So I think the concept is interesting. And I've never seen such a presentation before. Okay, still there is no question. So thanks, Malte, again. And I think we can end the session.
Thanks. Do you want to do some advertisements for the next session? And may you wish everyone a great start into the new year.
Yeah, that's a nice idea. So the next session, I don't think we have any scheduled for January, for the beginning of January. However, we have some in our back, don't know how it is called. So we have some potential sessions, and then there will be a session on February 4th, which will dive deep into the Kubernetes world and have performance analysis in Kubernetes. Yeah, so keep yourself updated on the webpage, and you won't miss any new news. And apart from that, I wish you a pleasant Christmas and a good journey into the new year. Stay safe and healthy.